everyone, welcome to our new episode of Video Lesson. I am Romer Ogamil, your teacher for this video. Our topic is all about absolute value function. So before we tackle the absolute value functions, here are some things we aim to learn in this lesson. First, we will learn about absolute value functions. Second, we will graph the absolute value functions and identify the domain and range. And third, we will use the absolute value functions to model real-life situations. Are you ready? So before we start or tackle the absolute value functions, let's have activity first. Okay, so our activity 1, state whether each graph represents a function or not a function. If it is a function, then identify what kind of functions. Number 1, it is not a function. Very good. Number 2, it is a function and it is a linear function. Very good. How about number 3? It is not a function. Very good. Number 4, it is function and it is a quadratic function. That's good. And number 5, it is function and what kind of function? It is a constant function. Very good. Number 6, it is a function. And what kind of function? It is a radical function. Very good. How about this one? It is a function. Very good. And it is the absolute value function. Very good. So in number 7, you know already that the graph of the absolute value function is a V shape. So what is an absolute value function? Absolute value function is a function that contains an algebraic expression within absolute value symbols. So always remember that the absolute value of a number is its distance from 0 on the number line. Right? So what is an absolute value function again? In the absolute value function, written as f of x is equal to the absolute value of x, is defined as f of x is equal if x is greater than 0, then your f of x is equal to x. And if the x is equal to 0, then your f of x is 0. And if x is less than 0, then your f of x is negative x. So to graph the absolute value function, first is choose a several value of x and find some ordered pairs. So for example, if our function f of x is equal to the absolute value of x, again, we will choose a several values of x. So for me, my value of x is negative 2, negative 1, 0, 1, and 2. Let's find the pairs of x of negative 2. So what is the absolute value of negative 2? That is 2. How about negative 1? That is 1. How about 0? 0. How about positive 1? Positive 1. How about number positive 2? That is positive 2. Always remember, there is no negative in the absolute value. In case if the sign negative is on the outside of the absolute value functions. Right? So let's graph. So let's plot the ordered pairs. In our Cartesian plane. So negative 2 and 2 found in the second quadrant. Right? How about negative 1 and 1? Still in the second quadrant. 0, 0 in the origin, very good. 1 and 1 are in the first quadrant, and 2 and 2 still in the first quadrant. So let's connect all the dots. So that is the graph of f of x is equal to the absolute value of x. If you observe that the graph is a V shape. So what is the vertex in our graph? The vertex of the graph is 0 and 0. How about the domain? The domain is the set of all real numbers. The range naman is the set of real numbers greater than or equal to 0. So, you know already how to get the domain and range. So, the domain is always the set of real numbers. But the range, it's the set of real numbers greater than or equal to 0 in the functions of f of x is equal to the absolute value of x. Let's have tackle about the vertical shift. The vertical shift to translate the absolute value functions. If f of x is equals to the absolute value of x, vertically, you can use the function g of x is equal to the f of x plus k. When k is greater than 0, the graph of g of x translated k units up. For example, g of x is equal to the f of x plus 4. Since your k in the g of x is greater than 0, so your graph vertically translated units up. What is the graph? So the graph is from the original, the f of x is equals to the absolute value of x. Since we add 4, so the graph is moving up, right? When k is less than 0, the graph of g of x translated k units down. So for example, the g of x is equal to the f of x minus 4. Since our k is less than 0, the graph of g of x is translated units down. So this is the graph. If our f of x is equal to the absolute value of x, then we subtract by 4, your graph is translated units down. Alright? Here, another is horizontal shift. Horizontal shift is to translate the absolute value function of f of x is equal to the absolute value of x horizontally. You can use the function g of x is equal to f of x minus h. So when h is greater than 0, the graph of f of x is translated h units to the right to get the g of x. For example, if g of x is equal to the absolute value of x minus 4, then your graph is going to the right because the value of your h here is greater than 0. Okay, when h is less than 0, the graph of your f of x translated h units to the left to get the g of x. So for example, g of x is equals to the absolute value of x plus 4. So before I show you the graph, maybe you have a question about your h here is less than 0 and my example is positive 4. So if we go back to our slides, the formula of the g of x is equals to x, the absolute value of x minus 4. Here is minus 8. Here is positive 4. So there is something inside in the absolute value. So in the positive 4, maybe, plus 4, maybe there is a negative multiplied to the negative 4. So it means the value of h is less than 0. So the graph is moving to the left. Right? So any question? So maybe some of you is have a question. So let's go. For an absolute value function is y is or f of x is equal to a multiplied to the absolute value of x minus h plus k. The vertex of the graph is the h and k, and the domain of the graph is the set of real numbers, and the range is y is greater than or equal to k when a is greater than 0, and when y is less than or equal to k when a is what? Less than to 0. So always remember the domain of the graph of the absolute value function is the set of all real numbers, right? And the graph is opened up if a is greater than 0 and opens down if a is less than 0. So always remember of that. And the graph of the y is equal to the absolute value of x can be translated if h units horizontally and the k units vertically to get the graph of y is equal to a multiplied to the absolute value of x minus h plus k. And the graph of y is equal to a times the absolute value of x can be wider than the graph of y is equal to the absolute value of x if absolute value of a is less than 1. Again, if the value of absolute value of a is less than 1, your graph is wider and narrower if the absolute value of a is greater than 1. Again, if the absolute value of a is greater than 1, the figure of your graph is narrower. If less than to 1, your figure of your graph is wider. Let's have example. Draw the graph and determine the domain and the range. So in the first example, f of x is equal to the absolute value of x plus 1 minus 3. So let's find what are the value of x or the set value of x. So to get the correct value of x, we will use the vertex. Vertex is the h of k found on our formula in the absolute value function that f of x is equal to a multiplied to x absolute value of x minus h plus k. So the vertex in our first example is negative 1 and negative 3. So we have x is negative 1 and the pair of negative 1 is negative 3. So you can find now the set of x. So the set of x are negative 2, negative 3, and so on, or 0 in the positive side, 1. So what is the pair of negative 3? To get the pair of negative 3, let x is negative 3 by using the given equation. So let's substitute the value of x, that is negative 3. So absolute value of negative 3 plus 1 minus 3, you got negative 1. Alright? How about in negative 2? if x is negative 2, so let's substitute the value of x is negative 2. F of x is equals to negative 2 is equal to the absolute value of negative 2 plus 1 minus 3, and then you get negative 2. If we continue to find the pair of 0 and 1, same process here. So you got negative 2 and negative 1. So since we have our ordered pairs, let's graph. So I have here the Cartesian plane. Let's plot the different ordered pairs. Negative 3 and negative 1 is found on the third quadrant. Negative 2 and negative 2 still in the third quadrant. Negative 1 and negative 3 still on the third quadrant. 0 and negative 2 lies on the y-axis, and negative and 1 and positive 1 and negative 1 found in the fourth quadrant. So let's connect the graph, the dots. So that is the graph of f of x is equal to x, the absolute value of x plus 1 minus 3. What is the domain? Again, the domain is the set of real numbers, or x such that x is the elements of real numbers. How about the range? The range is y such that y is greater than or equal to negative 3. Alright, let's have another example. Our given equation f of x is equal to the negative 2 multiplied to the absolute value of x minus 3 plus 4. So again, to find the set of value of x, let's get first the vertex. So what is the vertex of our given equation? That is 3 and 4. So since we have our vertex 3 and 4, so you can choose now what are the value of x. So the value of x is 4, 5, and 2 and 1. Alright, so let's find the pair of 5. If x is 5, what is the value of f of x? So f of 5 is equal to negative 2, absolute value of 5 minus 3 plus 4. So, and then 5 minus 3 is 2. So negative 2 times the absolute value of 2 plus 4, then that is negative 4 plus 4, that is 0. So the pair of 5 is 0. How about the pair of positive 4? If x is positive 4, then your f of x or y is what? That is 2. Very good. If you continue, so the value, the pair of 2 is 2 and 1 is 0. Again, if you want to solve the pair of 2 and 1, same steps, right? So let's graph. Let's plot all the ordered pairs. So 5 and 0 lies on the x-axis. 4 and 2 found in the first quadrant. 3 and 4 found still in the first quadrant. 2 and 2 and 1 and 1. Let's connect all the dots. That is the graph of f of x is equal to negative 2 multiplied to the x multiplied to the absolute value of x minus 3 plus 4. What is the domain? Again, the domain is the set of real numbers, or x such that x is the element of real numbers. And the range y such that y is less than or equal to 4. Why is it less than or equal to 4? Because our value of a is negative 2. So the graph is open down. Good. I have here the absolute value function to model real life situation. So while playing pool, you try A ball. The 8th ball is at 5 and 5/4, and the packet you are aiming for is at 10 and 5. You are going to bank the ball off the side at 6 and 0. So, write an equation for the path of the ball. And the question is, do you make your shot? So, let's try. So, Efren Batteries is master of this. So, let's write an equation for the path of the ball. So, first is the vertex of the path of the ball is at 6 and 0. So the equation has the form f of x is equal to a multiplied to the absolute value of x minus 6. Since we don't know the value of a, we will first solve the value of a. So substitute the coordinates of the point 5 and 5/4 into the equation and solve for a. So our equation f of x is equal to a multiplied to the absolute value of x minus 6. So let's substitute, and we have the value of a. So our value of a is equal to 5/4. So that's right. So the equation for the path of the ball is f of x is equal to the 5/4 multiplied to the absolute value of x minus 6. So you will make your shot if the point 10, 5, 10 and 5 lies on the path of the ball. So we know already that the path of the ball is f of x is equal to 5/4 multiplied to the absolute value of x minus 6. So let's simplify. So substitute 5 for y or f of x and 10 for x. Let's simplify. Okay, so that is our given equation. Let's substitute. F of x is 5 and x is 10. And then let's evaluate. So 10 minus 6 became 4, and then the absolute value 4 is positive 4 multiplied to the 5/4, that is 5/5. Means the points 10 and 5 satisfies the equation. So you do make your shot, right? This time, now it is your turn. Okay, so I have here the activity 2. Draw the graph and determine the domain and the range. Okay, so I have here 3 given equation. And activity 3 for the problem, the triangular arc of a tower lies on the coordinate grid. The lower left corner of the triangle is on the coordinate -4 and 0, and the lower right corner of the triangle is on the coordinate 4 and 0. The top corner of the triangle has the coordinate 0 and 8, assuming that the top corner is the vertex. What is the absolute value equation and that connects the vertex to the bottom left and the right corner? If you're done answering the activity 2 and activity 3, send your answer on my email. Okay? Thank you. I hope you have fun in our video lesson. God bless and keep safe.